Hi, this is Joe Bolen, and welcome to learning about VisualBasic.net. In this video, we're going to look at the concept of a class. We've been using a class when we have a Windows form. The Windows form itself is a class, but we're going to create our own user-defined classes in this video and learn about the concepts related to it. We've already taken a look at the module where we could have our methods and functions isolated in a specific container called a module that is publicly available to the assembly or to my project. Well, class goes a little bit beyond the concept of a module. It gives us a lot more power, and it also goes beyond the concept of a structure, which we haven't talked about, but you might have seen in other coding examples. So we're going to learn what is a class, and once you master the concept of a class, you'll discover how important it is to object-oriented programming and how it gives us so much power and versatility in constructing our code. So let's learn first of all about what a class is, and then we'll have a second video where we'll actually have a project where I'll create a class and use it in a Windows form. So let's take a look at our PowerPoint presentation where I have information about a class. So what is a class? Well, first of all, it is a blueprint, and I want to emphasize that that probably is the best statement. A class is a blueprint of an object. We work with objects and components all the time, but we're looking at a class basically as a blueprint. It hasn't been created yet. It's like the recipe that a cook might have for a meal, but until we actually create the object, it's only just a blueprint. We have to create it, and we do that by a special keyword we'll talk about in a minute. But let's talk more about the class itself. Within the class, we're going to have different attributes, or we might call them variables, that are public available, like we would have in other things we're working with, as well as methods and functions in our class. But we have to instantiate the object on that. We have to actually create it in memory. Just declaring it as a class alone is not enough. We have to say to the computer, we now want to make it into our memory. And we do that by instantiating the class into an object by using the new keyword. So let's take a look at an example of that. I'm going to create a student called add student, and that student variable name that I'm going to be working with is declared as a student, but I have to use it as a new student. And when I use that keyword of new, I tell the compiler or the system that I'm actually creating in memory a place for add student to have its data exist. So the new keyword instantiates our class into an object. Now let's take a look at why we want to create class objects to begin with. Well, we've been using them in our Windows form, but we also want to use them for a special reason. First of all, we can use the class to encapsulation. Basically, we're making a black box or data hiding the information that we're working with, so that we're only making it a pathway to get into, modify and hold information that we keep hidden from the user, so they do not need to worry about what's going on inside that class. Another part of it is inheritance. A class can inherit from another class. In fact, a lot of times we'll have maybe a very generic class. For example, if I had a vehicle class and then I had another class called automobile, the automobile class would inherit from the vehicle class all the properties and methods and attributes related to it. So we use the concept of inheritance with a class as well. Another one is called polymorphism. That's a little bit more difficult concept, but let's say I had a generic class called shape, and then I had another class called triangle or circle or ellipse, and those classes inherit from the shape class. Well, at that point, depending upon what object I'm working with, the circle or triangle or ellipse, the class will take on a different flavor or character to it. And that's what polymorphism is. It's a little bit more advanced concept, and you'll learn more about that as you develop more classes and learn the power of the class. Another part about the class is it can be an abstraction of a real thing in the world. It models things in the world. And in fact, we can have abstract classes. Classes that are never in and of themselves created, but they must be inherited by another class to be instantiated. So we can have very abstract concepts and generics created that are inherited by others. And probably the best part for me is maintainability and reusability of a class. If I create a good class, I can then have in that class all the things that I need that are related to that class. And if I have an error, I can go right to that spot to fix it. If I need to enhance my class, that's the spot where I also will go to work with. And if I have another project, I might want to import the class that I created from the old project into a new project, because that black box contains everything that I need for the new project I might be working with. Now let's take a look at a little bit of the differences. Well, a class, unlike a module, must be instantiated. We have to use that new keyword to make our class into memory. A module from the beginning of the run is in memory and is available to the assembly, or it can be made public to everything within our solution. Now, from outside the class variables are accessed through class properties. We could have in the class our normal public properties or public variables that we're used to defining, but instead of using public variables, we're going to use instead class properties that are public. And we'll use those because they have some special properties attached to them that make it more powerful than just a straight variable alone. And classes can be inherited. A module cannot be inherited. So I can have, like I said, a generic vehicle class that an automobile class might inherit, that I might then also have a truck class that inherits information about the automobile and the vehicle class. So we can inherit things that we already have out there as we work with it. For example, when we start out with a Windows form, in a sense we're inheriting the generic abstract form when we start out, and then we're adding to that form our own information. And so that is one way you might think of an inheritance on that. And then a class can also implement what's called an interface. Now that's another concept that's a little bit more advanced, but this is what makes a class much more powerful than just a straight module or a structure. Now let's take a look at a class in terms of some of the things we have in it. While classes contain methods and functions just like modules, they also implement properties. And you'll hear the term the class's properties instead of talking about a class's public variables that are available. Instead of declaring public variables in a class, public properties are declared. And also, classes have what are called special constructors to instantiate that class into an object. A constructor we'll talk about at the very end of this presentation. That's what brings about our instantiating our class into memory. Okay, properties. Let's take a look at properties. Properties have a get and set procedures attached to them, which gives us a lot more control on how the values are set or returned back to the user. The get procedure is a read-only access to the property's value, and sometimes we call it the getter. And then the set procedure, which we sometimes call the setter, is to write-only access to assign a value to the property. So we have getters and setters related to a class property. Now in Visual Basic or Visual Studio, we have a code snippet called prop, then hitting the tab key twice, that will generate for us a template or a snippet of the code that we might need to create a fully fledged property. Now let's take a look at a property out there by how we've defined a simple one called last name. You have what's called a backing variable, and this is a private property, or a private variable I should say. In this case I called it last name value. Now this will hold the information. Last name value will only be available within the class itself. From outside the class, this is not accessible, and it will have the information about the value whatever we assign to last name. Now the actual property itself is called last name, and here it's defined as a string. And if I want to bring it into my other perhaps a Windows form to get information, I get that through the getter part of that, where I return the private variable last name value. The setter part, though, is also where I assign to the last name, that backing variable, the value that I want to preserve. And here we can have, before we assign it, some kind of business logic code. In this case I have a simple one that if it's null or full of white spaces, then I'm going to throw an exception back to the calling part of the program that was trying to assign last name without a value, and tell the user that a last name must have a value. So we see here a very simple fully defined property where we can add some other logic to define how that value of last name must be maintained. Now we can also have what's called a auto-implemented property, and these are basically a bare bones version of the properties that have no special additional coding added and are simply auto implementation of the property. So here we see three of them. Here we have last name as string. We're not checking to see whether it's null or white space. We're just declaring it as a string and then giving an initial assignment of a string empty value. Then we have the one called quantity here. That's an integer, and it could be a positive or negative. We're not trying to regulate what is there, and so we're just simply defining a bare bones property called quantity. The last one, we made a read-only property called count, and probably through some other method that we have in our class, we'll be able to return back just the count of something we're keeping track of. So this is a bare bones, what's called auto-implemented properties. And the last part we're going to take a look at is the constructor of the class itself. Classes can have both a default and special overload constructors to instantiate the class into an object. Even if we do not declare a default constructor, the system in the background does have a default constructor being used. The difference is we can code it in and add to it. Now here is a default constructor, public sub new. And I've also had highlighted here, if this might have been an inherited class, I'd also have my base new inside of the sub new procedure. But this is the basic bare bones constructor, the default constructor, public sub new. Nothing else going on inside it. Now we can have what's called an overload, and this one here happens to be also public sub new, but the difference is it has a parameter list. In this case, it's passing in ID, first name, and last name. And then it's assigning those values to the properties in our class that we're working with. So we can have different constructors. We can have optional parameters as well. But we're going to take a look at only the basics at this point in this video and in our following video where we actually create the student class that we're going to be working with. So let's review. A class is a special container. It becomes like a black box. We have to instantiate that class with the new keyword when we declare it. And once we declare it, we then have access to the properties and methods and functions in that class. And we can use special properties to validate the data we're trying to add to the class, as well as any conditioning we have when we retrieve data from the class. So a class is a real special one, and we'll see that as a way that we model things. For example, in the video coming up, we're going to take a look at a student class. It's going to be a very simple class that we'll use to get an understanding of the concept of having classes in our project. And by doing so, we separate our class that we're working with from the graphical user interface Windows form class and keep things separate, so we can keep our business logic in one area and our user interface logic and things that we're doing with the form in another area, making it easier to maintain and work with, and make it also reusable. Because if I have a class I can make work in one project, it might be exactly the same thing I need for another project. And so a class is a great thing to have. It's a container that holds methods, functions, and properties in it. And it can do a lot more than just a structure or a module. So read up on the class and watch the next video coming up so you can learn how to code and use a class in your project. So take care and get your hands dirty in the code.